Good morning, students. This is KG Misra, and I have come with the next part of the video of the chapter Gravitation for class 9th. In chapter Gravitation, already we have discussed the gravitation part, and generally in CBSE, in the half yearly or midterm, the syllabus which is asked is up to gravitation part only. That means half of this chapter. The next half of this chapter, okay, that is known as flotation, okay, but it is under the same chapter, that is gravitation, but it is something different other than this gravitation, okay. But although they are different, then also they have been kept under the same chapter, same heading, and half of the chapter is taken for the first midterm, and the remaining half is taught after the midterm, okay. So I'm going to start the next part. See, so first topic in this is that is flotation, that is thrust. TH, thrust. Okay. Now, okay. Let's see, what is thrust? Actually, thrust is nothing but it is a force. Okay. When a force is applied in a perpendicular direction to a surface, then it is called thrust. Okay. See, this is the surface, this board, green board. Okay. I may apply force like this. See, I am applying force in this direction. So this is just parallel to this surface. Okay. And I may apply making some angle like this. See, this angle is there. I may apply the force like this. See, this angle is 90 degree. So this normal force when I am applying on this surface, then it is called thrust. Okay. So start writing the definition. Normal force acting on a surface is called thrust. Normal force acting on a surface is called thrust. Full stop. It is a vector quantity denoted by T and has SI unit Newton. Okay. Now, next is pressure. Next heading is pressure. See, what is pressure actually? Pressure we can define in two ways. We can define it using the force. See, what is pressure actually? When suppose I am applying force on the surface, normal force, okay, perpendicular to this surface. You can see my hand is perpendicular to this surface. Normal force I am applying, okay, and see when I am applying this force on this board, see my palm is covering some area, okay. So whatever force, normal force I am applying, that force upon the area covered by my palm is called pressure, okay. So it is, in words I can say, the normal force acting on a surface per unit area. Because see, if this total area is suppose A and total normal force applied is F, then on area A how much force is acting? F. So on unit area how much force will act? F upon A. And that force which is acting on unit area, that normal force which is acting on unit area is called pressure. Or we can define in terms of thrust, because we are using word normal force. So instead of normal force we can use the word thrust. So thrust acting per unit area is called pressure. So you can write like this: thrust acting per unit area is called pressure. Either of the way you can define it. So write the first definition using force. Start writing. Normal force acting per unit area on a surface is called pressure. Normal force acting per unit area on a surface is called pressure. write the next definition. Or, okay. Uh, Thrust acting per unit area is called pressure. Thrust acting per unit area is called pressure. Okay. Now, continue writing after full stop. It is a scalar quantity. It is a scalar quantity denoted by P and has SI unit Newton per meter square, because force has got unit Newton and area has got unit meter square. This thrust has got unit Newton and area has got unit meter square. Okay. So pressure is Newton per meter square. Or you can have some other units also, like in CGS unit, instead of Newton, what you can write? You can write dyne per centimeter square. That is the CGS unit. Okay. Now, what is the formula for pressure? Pressure is given by P is equals to F upon E or thrust upon area. Both are same. Okay. Now see how the questions can be designed from this formula. See, question can be designed like this. If area is doubled, then what will happen to the pressure? Okay. When area is doubled, then what will happen to the pressure? That means the force is kept constant. See, when you are keeping the force constant, then and you are doubling the area, so new pressure will be, let it be P dash. P dash is equals to F upon 2A, because area is doubled. So what do you find? What is this? F upon A. This is the earlier pressure. Okay. So you can keep the value of F upon A, that is equal to P. Okay. And if you keep that, what you will get? You will get P dash is equals to P upon 2. That means if the area is doubled, then the pressure becomes half. Okay, then the pressure becomes half. Okay, now next way round, if the area is halved instead of doubled, if we are having like this, area is half, then what will happen to the pressure? So let's look at this. Okay. Initially the pressure is like this, P is equals to F upon A. You are going to halve the area, but you are not changing the pressure force at all. So what will happen? Let the new pressure, that is P dash is equals to F upon area by 2. What do you think? This 2 will go to the numerator. As this 2 will go to the numerator, what we will get? 2F upon A. But my dear children, what is F upon A? My dear viewers, you will find that F upon A is nothing but it is pressure from here. So we can get P dash is equals to 2P. What does this indicate? This indicates that when you halve the area by keeping the force constant, then the pressure becomes double. Okay? Then the pressure becomes double. So this way the questions can be asked in this part. Even the straightforward numerical questions can be given, where you have to put the value of force and put the value of area and you find the pressure. Now, there are certain examples related to this pressure which you have studied in lower classes also, like class 8. See, the edges of the knife are made very sharp. What is the reason? The reason is that when the area decreases, see, I have made the area half, and what you found? The pressure became doubled. Even the force is constant then also. We human beings have got a limited muscular force with us, and with that muscular force only we want to cut the vegetables, okay, easily. So what we have to do? We cannot increase our muscular force, no? So what to do? How to increase the pressure? So for increasing pressure, what we do? We used to uh, sharpen the edges of the knife so that the area decreases. As the area decreases, the pressure increases without increasing the force. And therefore, it becomes very easy for us to cut the vegetables using knife. Suppose one of the person wants to cut the vegetables using a iron rod, then what will happen? As the rod has got wider surface area, so what you have seen in the previous case, when the area is doubled, then you found that the new pressure was how much? It was P by 2. So as the area of the rod is much more, so what will happen? For the same force, the pressure will become half. And that's why in order to cut the vegetable, you require more force. But our muscular force is limited. So what we have to do? We have to request Mr. Elephant or Mrs. Elephant, okay, to come and stand on that rod, okay, which is lying over the vegetables, so that vegetables will get cut. Okay. That means we have to increase the force if the area is more. Okay. And that's why we try to make it thinner, narrower, sharper. Okay. We don't use iron rod for cutting the vegetables. Okay. Now, another example. In sand, if we are walking, what happens? We are not able to walk properly. Okay. Why? Because our feet area is very less. And our weight is more. So what happens? More pressure is there because force is more and area is less. So pressure will be more. And that's why our feet gets inside the sand and it becomes difficult for us to walk. Our feet sink in the sand and that's why we find it very difficult to walk or run in the sand. But what about the camel? You know, camel is known as, okay, it is known for running in the sand, okay, or sandy areas. Why? What is the reason? Although it has got much more weight than us, then why it is able to run over there? Because see, in comparison to us, its weight is more, but at the same time, its feet area is much more than us. Okay, and therefore the net pressure which is acting, that becomes less than us, and that's why the feet of the camel doesn't sink in the sand, and so it becomes easy for the camel to run on the sand. Got it? So that's why it is called sip of sand, no? That is the reason. There are lots of examples of this pressure. You know, school bags. School bags of wider strip and cozy strip, they are costly one. Why? Because see, when the wider area is there, okay, then whatever the load of the books and notebooks are there in your bag, that will exert lesser pressure on your shoulders. So you will not find it difficult to carry it. But if some people have got very stylish bag, no, nowadays you will find people have got a stylish bag in which they have got a very thin thread is there, okay, which they use to hang the bag, with the help of which they used to hang the bag. As the area of that thread is very, very less, so what will happen? The load is same of the books and notebooks, so it will put more pressure on your shoulders and you will find the mark of those threads on your shoulder, red mark. Okay, it will hurt you. So it is always advised to select such a bag whose strips are wider and cozy so that it doesn't hurt you. That is where your studies are helpful to you. Why we get the education, why we study science, so that we can apply in our life and or make our life more easy to live and more enjoyable to live. And we can come out of difficulties, we can get the solution of difficulties. That is the reason we study science. It's not just going through the book and scrambling everything and that's all done. It's not like that. It is an applicable thing. It should be applied in life. Okay. Now let us take up a numerical over here, okay? A woman is there and her mass is how much? 60 kg, okay? She is wearing the sandal, okay? You know, sandals having very pointed heels, okay? So this the area of one pointed heel is 1 centimeter square. Now we want to convert into meter square. So what you have to do? See, 1 centimeter square means 1 centimeter into 1 centimeter. So 1 centimeter is how many meters? 10 raised to the power minus 2 meter. And this is 1 centimeter. So 10 raised to the power minus 2 meter. What you will get? 1 into 1 is 1. Centimeter into centimeter is centimeter square. 10 raised to the power minus 2 into 10 raised to the power minus 2. Bases are same. Power will be added. So 10 raised to the power minus 4. And meter into meter is meter square. Okay. So 1 centimeter square is 10 raised to the power minus 4 meter square. So we can write here 10 raised to the power minus 4 meter square. You may be writing like this also. 1 centimeter is how many meters? 1 by 100 meter into 1 by 100 meter. So this is meter, this is meter. So what you get? You get 1 by 10,000 meter square. 1 by 10,000 means again the same thing. 1 by 10 raised to the power 4 meter square. And if you take the reciprocal, you will get 10 raised to the power minus 4 only. Okay. So keep your concept clear and use always like this because it makes the calculation easier. Okay. So she is standing on 1 feet only. We have to find out the pressure she is exerting on the ground. Okay. For that, let us start. What is our force? Our force is the weight of the woman. Mass is given, it is 60 kg. G is given, it is, especially they are given 10 meter per second square in the question. And I have already told, if G is given 10 only, then we can use 10. Otherwise, we have to use 9.8. Okay. So here we are free to use 10 because they have given it. So how much force she is exerting on the ground? 600 Newton. Now, area is how much? Area is 10 raised to the power minus 4 meter square. Now, how much pressure she is exerting on the ground? So, if we go for the pressure, so pressure is equal to force upon area. So, force is 600 Newton and area is 10 raised to the power minus 4. So, what we will get? Just see 600. This 10 raised to the power minus 4, once it is going up, what we will get? 10 raised to the power plus 4. That means 10 raised to the power 4. That means we can write 6. What we can write this? Can we write it 6 into 10 raised to the power 2? And here 10 raised to the power 4 already there. So what we will get? 6 into 10 raised to the power 4 plus 2 6 because bases are same. So we can add the exponents. So this much Pascal. Newton per meter square or Pascal is the unit of pressure. Pascal was a scientist, okay? And after his name, this Newton per meter square is also called Pascal. P-A-S-C-L-E. Pascal. Which is denoted by PA. Okay? Just note down this and then I am going to tell you a story. Done? See. I am going to have this side. We know that P is equal to F upon A. Okay. So when force is 1 Newton and area is 1 meter square, then pressure is 1 Pascal. Okay. It is 1 Pascal. There is a small story related to this. The scientists were playing hide and seek. You know, I Spice, hide and seek. Okay. So, the Galileo was there, he was giving 10. And he gave, wait and closed his eyes and started counting 1, 2, 3, 4, 5, 6 like that, okay. And after counting 10, he just came and he had to find the other scientists, okay. And whoever he finds first will have to give the 10, okay. But if in between any of the scientists comes from backside and gives dhappa, you know, then what will happen? Then again, Galileo has to repeat, he has to give the 10 again. So everyone found the place to hide, but Newton never found. So what he did, he just made a circle of area 1 meter square. And he was standing over that, in that circle. in the open, in the ground only. The Galileo came and he first saw the Newton because standing in the open. He told, okay, Newton I suffice. And then he went and found everyone. When he found everyone, then he told, okay, now Newton had to give the 10. Newton told, no, why should I give the 10? You have not seen me. You don't know I saw you. I saw the Newton. Yes, you might have seen the Newton. Newton told, yes, you might have seen the Newton, but I am not Newton. Everyone surprised to hear this because he was Newton only. He told, I am 1 Newton, no? Yes, Galileo told, yes, you are 1 Newton. And then Newton replied, I am standing on the area of 1 meter square, no? So 1 Newton is standing on the area of 1 meter square. So I am 1 Pascal. But you told Newton I suffice. But I am Pascal because 1 Newton is standing over an area of 1 meter square. So Pascal has to give the 10. Why should I? Because 1 Newton is standing over an area of 1 meter square. So I will not give him the 10. So that means when 1 Newton is standing over the area of 1 meter square, then it is exerting a pressure of 1 Pascal. Okay. It is not Newton. That's what the Newton sent the message. Okay, with this I would like to end this class. Okay, and I hope you are very fine on studying also. God bless you all. Bye bye.